Hey everybody, welcome to Earth and Time, a channel that explores both human history as well as Earth history, and specifically where those two places intersect. And today I'm really excited to take you all to one of those places where they intersect, and maybe in a way different than how we would normally think about it. Often I talk about things like ghost towns, where of course geology helped in place things like gold and silver or other precious minerals. But today we're going to talk about these amazing rocks behind me known as Vasquez Rocks, and the geologic history of them, how they ended up this way, and how, because of their shape and their look, and also the location here in Southern California, they influenced the movie industry and a lot of pop culture. Come join me, let's check out Vasquez Rocks. Let's learn a little bit about both the pop cultural history here as well as the geologic history and how they intersect. Let's get to it. What I want to do is actually start by coming here to the Interpretive Center and see if they have a little bit about the geology here. So to start off with, we really need to talk about the setting of why the geology is what it is here. And really it's a result, if we take a look at this map, of the Pacific plate running into the North American plate, which has created what is known as the San Andreas Fault zone. And here we have what's called a right lateral strike slip fault system. And they actually have a nice diorama. So we're sitting somewhere in the Interpretive Center area over here, and we're going to work our way over and take a look at the Vasquez Rocks main section right through here, where we can actually see these, what they call hogsbacks, popping up. All the rocks here are known as the Vasquez Formation, and you'll see the lower Vasquez Formation is about 1,300 meters thick, so you're looking at somewhere around 5,000 feet thick, and it was deposited between 25 and 23 million years ago. You have the main Vasquez Formation, which is really thick, almost 6,000 meters, so you can think about 3 miles thick plus, and that was deposited about 20 million years ago in one of these big basins. And then they have something called the Mint Canyon Formation that's on top. The LCU was deposited 16 to 10 million years ago. Probably what Vasquez Rocks is best known for are all the movies that have been filmed here, from John Wayne to Lone Ranger movies to 1 million BC with a Dimetrodon crocodile thingy. Not sure what that is. But there's been so many movies filmed here. Of course, Blazing Saddles is one of the classic ones. Of Star Trek, they have this little diorama, and probably one of the most famous scenes from any show that was filmed here in Vasquez Rocks was actually this scene from the original Star Trek series, what they were calling the arena, where Captain Kirk fights a Gorn lizard person. Probably one of the most famous scenes. Of course, it takes place at the rocks here. Other sets were Flintstones. You can see they did Planet of the Apes. I guess I have a scene from Wind Talkers, which is a great movie. I haven't watched it in a long time. I guess that they actually don't have included here is actually Army of Darkness, which is a Sam Raimi film, Bruce Campbell, one of my all-time favorites and a cult classic, and one me and my friends probably watched hundreds of times. All right, from the Interpretive Center, let's see if we can find this geology trail and learn a little bit more about the rocks that we're looking at here. All right, so I found the geology trail here. So we're going to start here. It looks like it's a pretty short trail. I'm going to work my way up, over, around, and then just work my way probably back down the trail here, back to where I'm parked, so we can learn a little bit more about the rocks here. And here's actually a whole poster on this. This is fantastic, and kudos to this park for putting this together. End up with a valley that's here, and in this valley you have a bunch of mountains starting to pop up around it. And so wherever you have a valley and there's mountains around it, all that material is going to go down into those valleys. And that's what we have here. The Vasquez Formation is made up of a bunch of what we call conglomerates and sands, which we can see here, that are all deposited from these mountain ranges. We can see similar things today, especially if you head out towards like places like Victorville or Barstow. You'll see these big fans coming off the mountains. And what's amazing to me are the ages, and we saw these inside the Interpretation Center as well. But so these basins were forming about 25 million years ago for the lower Vasquez Formation, and continue to form for over 5 million years. And then eventually there was something called the Mint Canyon that came on top. And now we know these were basins, and now they're all exposed, and that's due to, again, the faulting here. So why are all these rocks up at an angle like we can see in front of me here? Well, it turns out we're in between the famous San Andreas Fault zone, a big right lateral strike slip fault zone, and the San Gabriel Mountains, which also is a right lateral fault zone. So where you have two right lateral fault zones having pressure going this way and pressure going this way. So you're squeezing this whole area and you're popping these blocks up in between. And there's a couple other faults here called the Elkhorn Fault. You'll see the Francisco Fault here, the Clearwater Fault. All these faults are helping the Vasquez Rocks to pop up and then rotate. And that's actually why we have the amazing geology that we have here at Vasquez Rocks. All right, let's start walking through the geologic interpretations here. I'll make some observations along the way as well. As a geologist, I always look at these kinds of places, especially somewhere I've never been before, like Vasquez Rocks, and I start looking for clues to help me understand the story. So the first thing I'll point out as I come up here is I can actually see, as it looks like this is a bunch of orthoclase or granites, and so geologists can probably find out where this originally came from. Probably somewhere in the San Gabriel Mountains would be my guess, because you have some igneous rocks, so these would be igneous in origin, but we can see they're all different sizes and they're very angular. And this is a classic type of deposit we see in things like alluvial fans or deposits coming off of mountains where they haven't traveled very far. So maybe one rain event takes them down and they flood down in the valley, but they haven't traveled far enough to be rounded like you would think of gravels, like in streams or along beaches. So this does give us a hint about provenance or the origin of this material. And I can actually see this pattern repeated again and again right in front of me here. So here's another one of these, probably some kind of alluvial fan deposit, but in between one alluvial fan deposit and another one of these gravelly, angular type of deposits, we actually see some finer sand. Here we go. If I would have just walked a little farther, we could have seen this. And this is talking about exactly the observations I was just making, is that we have these sandstones that were probably related to some kind of stream deposits, maybe some kind of edges of lakes. We have also what they call conglomerates. So conglomerates are going to have slightly more rounded pebbles and cobbles with them. And I'm actually not seeing a really nice example of a conglomerate here, but I am seeing a lot of breccia. And so that's that irregular, angular type of material that you'll see. And this one kind of falls maybe a little bit between the two, because I do see some slightly rounded pebbles in here, but also some angular pieces. Well, this is fun, looking at this and seeing that they put together this geologic trail for us all to learn. Here's a nice breccia, and now you can really see these angular pieces, all different sizes, all kind of tossed together in some kind of flooding event, kind of a slurry that came down from the mountain. And of course, I'm here to look at the rocks as a geologist and paleontologist, but it is cool seeing the different life that's here as well, including various species of birds, some kind of falcon here, absolutely beautiful, by the way. Lichen, which we can actually see some lichen and mosses on that rock just on the other side of us. And I imagine there's other squirrels and maybe some bobcats or maybe some ringtail cats that could live out here as well. Coyotes, probably out here, and rabbits all live amongst these rocks. Now, I talked about the idea that these things were originally deposited horizontally, right? So if you imagine rivers and beaches today, they're not being deposited like this. They're deposited horizontally, and then they had to be rotated. So this tells me there were a lot of tectonic events, a lot of earthquakes, a lot of deformation had to happen in this area to turn these beds from horizontal to vertical in, about 45 degrees. Continuing on, and we're coming up to what is known as the colors of Vasquez rock. And this is pretty neat. So it's actually talking about what's contributing to all these different colors we see. The red here is really from iron oxide. It's a hematite cement that's keeping these rocks all together. And then what can happen through often biologic processes, you get what they call a desert varnish or patina on the rocks here from actually biotic activity, and it's a manganese oxide which creates this black color. So the colors we see in these rocks tell us something about the cement that put them together, and also a little bit about their source, where they're coming from, as well as, in many cases, how water moved through them, which also helps deposit iron and other kinds of precious minerals inside of rocks. In this case, I don't see a lot of evidence for things like gold and silver, but we definitely see the iron staining going on. It really is an otherworldly landscape out here, and I can see why individuals from Hollywood would come here and film. You could come out here and create the Old West. You can come out here and you can create an alien planet or something fantastical. And so we can actually see where there's been some what we call differential erosion. So you'll see where it's more eroded in the middle versus what's happening on the left-hand side here to my right-hand side. These layers in the middle may be finer material, may have less cementation, or may have had some just enough differences that water and wind are actually able to erode through more readily than the material on the left and right. Kind of neat to see that as well. It really tells us a lot as geologists about what the rocks are made up of and how well they're cemented. And again, I seem to be ahead of the story here as I turn around to actually talk about this idea of what's actually shaping these rocks. And again, talking about this idea of weathering, so wind and water coming through these different layers, especially as they've been rotated up through all the seismic activity and series of earthquakes. So it's great as I'm walking through this and I'm making the observations and then turning around a corner and seeing the sign there. I'm really impressed by how the individuals that put together the geologic trail here have thought through it. It's the same way I think through it as a geologist. As I walk around, I make observations, and then from those observations, we can start making interpretations. Now that's a really cool sight to behold. There's the famous Vasquez Rocks from all the different movies sticking up in the air, the hogbacks. Remember, we're going from older Vasquez Rocks that direction and getting younger this direction. Remember, it's like if my fingers were here and then rotated and my pinky's the youngest. So you can get a real idea about the geologic time frame here. As both a geologist and somebody who really enjoys film history as well as human history, it is so amazing coming to Vasquez Rocks here, being somewhere that both geologically is absolutely stunning, amazing history. We can see the earth processes at work, but not just that, but we can see how these earth processes have influenced pop culture. Things like the filming of Star Trek here, the John Wayne movies, the Flintstones, Army of Darkness. A number of music videos were filmed here as well. Rihanna, One Direction, Tom Petty. So really neat to see how geology has influenced pop culture in a big way. So I'm going to just say geology is the coolest. All right, so I moved down the road and now we're getting to the classic Vasquez Rocks that everybody's familiar with from the movies. In fact, I believe it's this view and this pathway that there's a movie by Sam Raimi I mentioned earlier called Army of Darkness, one of my favorite movies when I was in college, Shop S-Smart, where this is the pathway going to find the infamous Necronomicon to stop the army of the dead in that movie, and Bruce Campbell has to go down the trail here and hilarity ensues. If you haven't seen it, it's a cult classic, pretty fun movie, and this is that scene. Now, when I was on the Geology Trail, I already mentioned a number of the other movies filmed here. Of course, the most famous scene in film history was actually an episode of the old Star Trek original series that aired January 19th, 1967, called The Arena, where Captain Kirk is in these rocks fighting a Gorn captain. Again, as I can look at the geology here, and I can look at this face sticking up, and I can see the large boulders that are sticking out from some of these old breccia deposits, these giant alluvial fans that were coming down into these basins. So once I end up on the other side of the rocks here, we'll take a few minutes. I brought my trusty whiteboard with me so we can talk about how these systems deposited. All the Vasquez formation was laid down in a basin, and then we can talk again about how they were actually uplifted and rotated. So what I've done is use my trusty whiteboard here, which by the way needs a name. So if anybody has a good name for my whiteboard, please let me know. maybe Willie, maybe Walt the whiteboard, I'm not sure. So if you have a good name, let me know. But what I want to do is show my whiteboard here, use my whiteboard, so I can show you generally how the Vasquez Formation was deposited. And what happened is when those two plates, the Pacific Plate and the North American Plate, were initially running into each other, there was actually more subduction going on. So what does that look like? So if this is the Pacific Plate and this is the American Plate, the Pacific Plate actually started off by subducting underneath the North American Plate, which actually ended up creating a lot of volcanoes and volcanics. Eventually that would turn and move and eventually rotate and become a strike-slip fault, a right lateral strike-slip fault. So North American Plate's moving southerly, Pacific Plate's moving towards the north, and it would create a bunch of other faults in there. But in that initial contractional or compressional event, you actually ended up also getting some what we call extensional faults, or the idea that land was sliding down, is being pulled apart, which creates space, which creates these down-thrown blocks we call grobens, and the up-thrown blocks called horse. So if I draw that on here, the black line goes to the black line, goes to the black line here, and I've actually shown you some normal faults. So these come up, these are the horst, these go down, those are the grobens. And as this basin is forming going down, these mountains are shedding material into the valley. And in this case, this valley was miles and miles thick. And there's actually multiples of these valleys across this region about 25 million years ago. And so they filled up. So each of these colors are different timelines, if you will, of material coming in. So you kind of have early fans coming in, maybe some streams coming down, and then you have the next set. And if you remember, it was like the lower Vasquez was about 25 million years old. The next set was about 20 million years old. The mint was somewhere around 15, 16 million years old. And so they were filling up this valley. So that's how you got these sediments in here in the first place. Now, the next question from there is, okay, so we've created this big, thick valley full of sediments. So what happened next? To create all that thick valley sediments, which should be far below our feet at this point, pop all the way back up to the surface and get rotated and eroded like we see here. So we started off by looking at what we call a cross-sectional view, showing that horst and the grobens. Now I'm going to show you a map view. So it's like we're up in outer space looking down on Southern California, looking at the primary faults and how they're interacting with one another, which actually popped all this material up. All right, now that I've re-sketched what's going on Willie or Walt the whiteboard here, what I want to talk about is what we're looking at. So we talked about how we created that basin about 25 million years ago, and it just kept sinking, filling up with a bunch of sediments. Well, then you had a reorientation of the fault zone somewhere probably around 5 million years ago, when the present day San Andreas Fault ended up in its position it's at now. And what I am showing here on this whiteboard is I'm showing, here's the coast. So this would actually be north if we're looking at it that way. So here's roughly the coastline. Here's the ocean. If we come in from the ocean, there's actually a series of faults, but there's a very large fault here called the San Gabriel Fault Zone. And it's what we call a right lateral fault zone. So that means the material on the right-hand side is actually going north. The material here on the left side of this, or the east side, is going towards the south. Now, next to that, on the other side of those mountains, you have what's known as the San Andreas Fault Zone or fault line. And most people are pretty familiar with that because that's a major active fault zone that's out here, as is actually the San Gabriel. But the San Andreas Fault is, if you will, the main fault, really controlling a lot of the motion here, moving, somewhere around an inch a year or so, maybe a little bit more, up to almost 2 inches a year of movement. So pretty active fault zone. But what happens is it is also a right lateral fault. That means the east side is going towards the south, the the west side is going towards the north. And where these two arrows point towards one another, you're actually ending up with a contractional or compressional system. So you're taking the whole land there and you're pushing it together. Well, if we had a big, deep basin and then we start pushing it from either side, it's going to pop that basin up. So it's like taking a carpet and pushing it up against a door jamb, right? And you get it crumpled. So you have a certain amount of material and it has nowhere to go but up. And so that's what's happening here is Vasquez Rocks is caught in between the step over between these two fault zones. Now, there's some other fault zones like the Elkhorn Fault that splays off of this, that controls maybe the northern boundary of this. But the Vasquez Rocks, as they're being squeezed, they were nice and flat like this. They're being squeezed, so they're being rotated upwards. Now, as they're being rotated upwards, they're also starting to erode, which gives us these hogback shapes that we see in front of us. So absolutely amazing story about multiple episodes of what we call tectonism and plate tectonics that created a deep basin here, miles deep. And then because of later compressional forces, really over the last 5 million years, they've squeezed and popped these hills up. And of course, they've been eroded to look like what we see today. Absolutely fascinating story and an amazing geologic one. And of course, again, because of the amazing geology here, it's influenced the film industry and so much of pop culture. So yet another place where human history and Earth history interact and intersect, and how one plays an important role on the other. Specifically, so for all my Bill and Ted fans, here are the cliffs where in Bill and Ted's Bogus Journey, the evil robots threw Bill and Ted off of the cliffs here, and they came down here, and of course, that's how they ended up challenging death, and again, hilarity ensues. I like all these little, I don't know what kind of birds those are. Maybe somebody can tell me what those are, but they're absolutely beautiful. They're black and white, and they have their homes in the rocks up there. This is the scene, this is the view from all of those movies I talked about before. All right, so here's a slightly different view looking along what we call strike of these beds. So that's along the bedding plane. Dip is what we call it with the angle. So here you can see the dips are close to 45 degrees or so, maybe even up to 50, 55 degrees. And the strike is going in that direction, but it gives you a very different view, and you can really see how much these beds have actually been rotated due to the compressional features between the San Gabriel Fault Zone and the San Andreas Fault Zone. I worked my way up a little farther, and in fact, you can see these beautiful breccia beds. So these would have been these alluvial fans coming down, and then interspersed sands coming down with different storm events. Maybe this whole thing would be one big rain event or storm event. Brought a bunch of material down. The last part of that, the heavier material comes out, deposits first, and then you get sand, and then you get repetition of these beds over and over again as you have big rainstorms in the mountains. They come down, they basically create flash floods, they deposit out, and that's what we're seeing going all the way up, again with these breccias, in some places conglomerates, and we can actually see the scours where these later events, flooding events, came through and scoured out some of the sand. So that's a little mini channel right there where you can see the coarser material eroded out the sand material, which is exactly what happens when you have these big flooding events. Really cool to see that story here and put it together with knowing we were in this old basin 20, 25 million years ago. One other thing we can see down here is we can actually see some cross beds as we continue up here, which is also another kind of common feature we'll see in the swoop pattern associated with water moving through a system. I've turned around and I'm facing towards the south, and you can actually see more of that Vasquez formation over there off in the distance. And we can see as we pan to the right, we can see all the layers are actually dipping. So they've all been rotated from horizontal to dipping. And so we're getting younger in section looking across the freeway there. I believe that's the 14 maybe that's coming through there. And we can see how these beds have been rotated, all part of the same story. Just don't have as much of that unique erosion that we see here that of course made Vasquez Rocks famous. I moved vantage points, and what's really interesting is if you can see kind of from the base here, you come up a little ways, there's actually a big fracture in there. And actually it looks like it's got a little bit of movement and maybe a small fault, definitely a fracture going through the side of the mountain right there, or a Vasquez Rocks. And that's pretty cool to see. In fact, there's even a spot a little higher up where you can see a little boulder is offset just a little bit up there. So
That, my friends, may be the start of a fault that's going to cut through here eventually and eventually drop down or offset some of these features or pop them up a little bit more, depending on which way that fault decides to move. All right, everybody, grabbing some shade here to say goodbye, and thank you all for joining me today to learn about the geology of Vasquez Rocks, as well as where geology really meets Hollywood here, which really is the theme, I guess, of this episode, is that this amazing scenery behind me, created by that geology, has led to amazing scenes and fantastical places that Hollywood has used over and over again for all kinds of different things. If you enjoyed this episode and you haven't already, please subscribe to my channel, hit that bell for notification to keep up on all my latest adventures where I explore Earth's history, human history, and where both intersect. If you enjoyed this episode specifically, please give it a thumbs up. Please leave comments down below. Have you been here to Vasquez Rocks? Do you have any other information to add down below to all the other subscribers here and all the other folks who are watching these videos? We all learn together, is what I like to say. All right, with that being said, I appreciate all of you joining me today, coming to you from Southern California here, Vasquez Rocks. Everybody take care. We'll see you all in the next adventure. Bye for now.